Okay, I'm going to do a few Hess's Law problems for you so you can watch them being walked through step by step. Remember that we're usually given an equation that is a target equation, what we want to end up getting to, which is one we do not have the enthalpy value for. And then we're given some given equations, which we do know the enthalpy value for. So the given equations, remember I told you I usually label them as equation 1 and equation 2. These are the givens that we know. So in this particular equation, I'm going to start with the beginning. So I will see that in this particular target equation, equation number 2 is where I'm going to start with this compound. I need H2CO in the reactant side with a coefficient of 1. I have CHCO with a coefficient of 1 in equation number 2. So I do not need to do anything to equation number 2. I can use the whole thing as is. Next thing I'm going to say to myself is I need carbon dioxide in the products. So you could do H2CO, then do O2, then do H2O, then do CO2, whatever works for you. But for me, I can recognize that when I used equation 2, as is, I got my H2CO and my O2 taken care of. And I already used equation number 2, so I need to figure out how I'm going to use equation number 1. So equation number 1 has CO2 in the reactant side, but I need it in the product side. So I'm going to flip equation 1. When I flipped equation 1, I also have to change the sign to positive 77.5 kilojoules. So now I'm going to go through and be like, okay, where am I at? I have H2CO where I need it. I have O2 where I need it. I have H2O where I need it. And I have CO2 where I need it. I also have H2CO3 in the reactant side and H2CO3 in the product side, both with a coefficient of 1 so that they cancel. Remember, I have to make sure I have everything that I need where I need it with the right coefficient, and everything else needs to cancel. So because I canceled everything I didn't need and I have everything I do need with the right coefficients, all I have to do now is add up the enthalpy values. So in your calculator, you got to be very careful. Use the negative 140. So that's negative sign. And then I always do plus 77.5. I always add them together, whether I have to use a negative sign or not. And I get an answer of 62.5 kilojoules. Okay, let's do another problem. This time we're given 3 equations that are known to us to get to this target. So I'm going to start from the beginning again. I'm going to say I need OF2 in the reactant side with a coefficient of 2. I look down at my 3 equations. I'll label them 1, 2, 3. I'm going to recognize that equation 1 has OF2 in the reactants, but it only has a coefficient of 1. So I'm going to have to take equation 2 and multiply it by 2, which will give me 2OF2. I don't need to pay attention to the states of matter because nobody changes states of matter just in this equation. Anytime you have states of matter that remain consistent, you can kind of ignore them. And then we're going to have 2 times minus 276.6. Next, I need sulfur in the reactant side with a coefficient of 2. So I'm going to look at equation 3 and see that I have sulfur in the reactant side, but it only has a coefficient of 1. So I'm going to multiply that by 2. So I'm going to multiply everything by 2. Like such. And that means that I'm going to multiply 2 times minus 296.9. Now I'm going to go to this last equation. This last equation has SF4 in the reactants. I need SF4 in the products. So what I'm going to do to equation 2 is flip it. So my products become my reactants, and my reactants become my products. And now I'm going to change the sign on my enthalpy to positive, like such. So let's see where we're at now. I have 2 OF4 in the reactants. I have 2 S in the reactants. I have SF4 in the products. And right now I have 2 SO2s, but let's check this out. One of these SO2s is going to cancel, leaving me with 1 SO2. Now I have to double check that all the things that I don't need cancel. So I don't need oxygen, and I have 2 in the reactants and 2 in the products. I don't need water. I have 2 in the reactants, 2 in the products. And I don't need HF. I have 4 in the reactants, 4 in the products. So everything I don't need cancels, and everything I do need is there in the right quantities. So my last step is simply to add up in your calculator 2 times minus 276 plus 827.5 plus 2 times negative 296.9. Get a final answer of minus 319.5 kilojoules. So there's a couple more examples of Hess's problems for you guys to try to understand Hess's law.